Hey, I'm Bob and I like to make stuff. Today on Maker 101, we're gonna get you coding for the Arduino. So this is part 3 of my series on programming for the Arduino. If you haven't watched parts 1 and 2, I suggest you go do that now. Also, you might want to watch the Maker 101 that's about the Arduino hardware and the one that's about circuits. In parts 1 and 2, we talked about some general programming ideas, some words that you're going to run into, and some concepts that you needed to know. In part 2, we set up your Arduino, got your development environment ready to go, and now we're going to write some code. If you have seen all 4 of those videos, or at least parts 1 and 2 of this series, you are ready to go. So now we're ready to make a small project, and there's 2 parts to that. We need to wire up a circuit, and we need to write some code. So first, let's look at the circuit. This is just an example. It's kind of a useless circuit, but it gives you an idea of how the code translates to real-world stuff. So let's talk about the components that we're going to use for this simple circuit. We're going to have an LED and a resistor. Then there's the potentiometer, which is a variable resistor. As you turn the knob, you're changing the amount of resistance, so it lets a different amount of voltage through. We'll use some simple jumper wires and a breadboard. And if you don't know about a breadboard, it's a really great tool for prototyping a circuit. You don't have to solder, you can just press wires into these terminals. The terminals are set up so that each row is all connected on the inside of the board. So if you connect 2 wires to 2 terminals within the same row, it connects those 2 wires. Along the outside edges of both sides of the board, you have terminals that are connected from one end all the way to the other, and these are usually used for power on one side, ground on the other. That gives you access to power and ground on the breadboard no matter where you're working. So here's how we're going to wire up these simple components. If you refer back to the video that I did about the Arduino board itself, you'll remember that one side has analog pins, the other side has digital pins. We're going to use both in this case. We're going to use the digital pins for the output, for the LED, and the analog pin for the input, because it's going to take an analog input from the potentiometer. So hooking up the potentiometer, we put one side to ground, one side to 5 volts power, and then the center terminal goes to the analog input. Next, we're going to hook up the LED. One important thing to remember about LEDs is that they do have a specific polarity. There's usually a shorter and a longer terminal. The shorter one is called the cathode, and it's the negative. The longer one is the anode, and it's the positive. In this case, we want to hook up the shorter one, or the cathode, to the digital pin that we selected on the Arduino. Then the anode gets connected to a resistor, and the other end of the resistor goes to 5 volts. The last thing is to take a couple of jumpers and run from the 2 outside rails of the breadboard to the 5 volts and the ground on the Arduino. That's all the wiring that we need to do for this project. So what is this example project that we're building? It's really simple. We're going to have an LED that flashes, then we're going to use the potentiometer to change the speed of that flashing. It's a basic example that shows us an input and how it can control an output. So now let's look at the code. So we start out by creating 2 variables at the very top of the file. These are both integers, and they're going to represent the pins that we're using to plug in our LED and our potentiometer. And by pin, I just mean the numbered slot on the Arduino itself that we're plugging stuff into. So each one of those variables gets a value, and in this case, the potentiometer is in pin 0, the LED is in pin 2. Next, we need to fill out the setup function, and there's not a whole lot that happens here. Basically, we just want to tell the pin that the LED is plugged into to be an output rather than an input. We do that by calling the pin mode function. It takes 2 arguments, the things in the parentheses, and those arguments are which pin we're talking about and how we want to use it. In this case, we're going to use our variable LED pin to say which one, and then we're going to say output because we want it to be an output. The real work that's going to be done in this sketch is in the loop. Inside the loop function, we create another variable called delay timer, and it's also an integer. And then we fill that with a value from calling the analog read function. Analog read is a built-in function that takes one of the analog inputs and takes its value. And we have to tell it which one to take. And in this case, we're using our pot pin variable, which tells it to go to the pin that our potentiometer is plugged into, read a value, and then return it into our variable that we've just created called delay timer. So at this point, we're just getting a number out of the potentiometer. If you turn it all the way down, that number is going to be 0. If you turn it all the way up, that number is going to be 1023. So at this point, we have a value from the potentiometer, and now we want to use it. First, we're going to turn the LED on, and you do this by using a digital write function. Digital write takes 2 arguments, the stuff in the parentheses. First, which pin we're talking about, and how we want to set it. So we give it our variable, that's the LED pin number, and we tell it to set it to high. There's 2 states for this one, high and low. High means on, low means off. So with that one line, we turn the LED on. The next line is the delay function, and all it does is put a pause in the code. The only argument it takes is how long it needs to pause, and we're going to give it that value from the number that we're getting from our potentiometer. So we give it our delay timer variable, it pauses for that long and then it moves on. As you can see, the next line is another digital write, but instead of writing high, we're writing low. So in this case, we're turning the LED off. The last line is another delay exactly like the one before. So to summarize, in this loop function, we read the value from the potentiometer, we turn the LED on, we wait, then we turn the LED off, and then we wait again. The loop is over, but then the loop runs again and again and again. So all we're really doing here is telling it how long to wait before it turns the LED off and then before it runs the loop again. And we're reading that number from the position of the potentiometer. So with one click of a button, I compiled that code, uploaded it to the Arduino through the USB cable, and here it is running. As you can see, the LED pulsing speed is changing as I turn the potentiometer. No, it's not very exciting, but it is doing something. It's doing exactly what we told it to do with the code. I hope you followed along with that, and if you did, then you just built and coded your first Arduino project. Obviously, this is a really simple example, but the idea is the same once the project gets more complex. You have inputs that you can assign, you take their input values, you do something to them, and then you create output values. And that's really all there is to Arduino, and really to computing in general. Anyway, I really hope that this series has given you a little push to go learn some more and to get started programming your own projects. I've got lots of other Maker 101 videos if you want to go back and check those out, as well as a whole bunch of different types of projects. If you have some cool stuff you want to share with me, I would love to see that. You can tag me on Twitter or Instagram. You can post things on my Facebook wall. I love to see what everybody's working on. That's it for the Arduino programming series. I'll be back with another project really soon. Thanks for watching, guys. I'll see you next time.